Acceleration and displacement, part one. All right, so up until this point, we've been only really using two formulas. We had this one for constant velocity or uniform motion, and this one for acceleration. That's been it, right? And we've been kind of focused on that. So you really just had to plug in and only use that one. What we're gonna start doing now, though, is I'm gonna all of a sudden bombard you with four new equations, and we're gonna have to figure out when to use which one. So first off, though, I want to show you on your formula sheet, if we can get there. Yeah. Okay, so on your formula sheet, you can see that we're in the kinematics unit up at the top here, right? And you had the first one, the second one, that's what we've been using, but we've been putting in VF minus VI at the top. You have to remember that. And now what we're doing is this one, this one, this one, and this one. So we're doing everything except for these bottom two so far. All right, so there's those six that's in our repertoire of equations as of this moment. Okay, so if I go back here, so what we're just introducing now is displacement, and we've still got v1 or vi t plus 1/2 at squared. So they're becoming a little bit more complicated with like the t squareds and stuff too. But for the most part, they're all really straightforward, I'd say. I don't know. All right. As we go on, look to page 46 to 53 in your textbook. It goes over this stuff well too, and maybe from a different angle that you might like instead of me. What I'd like you to start doing though with these questions, just because now we have to figure out when to use what. Here is our general way that we're going to solve problems now. So you're going to read the question, understand what's being asked for. Extract and write down known and unknown variables. So this is where it comes in handy to write down what we have and what we don't have. Select and write down the equation which contains the variables listed. It does not matter what order the variables are in or which one is unknown. So I'll show you what I mean by that in a couple examples here. Manipulate and rearrange like we did at the very beginning of this course with the transposing formulas. Substitute in the known variables along with their units. Solve for the answer. Circle or underline the final answer. Remember to include units and direction if it's a vector that you're looking for. Okay, so example 1 says an object traveling at 10 meters per second accelerates until the final speed becomes 20 meters per second. If the time interval was 5 seconds, how far did the object travel over the interval? Now, it's all fine and good because I gave you, really you can see which formula to use here. But what if I didn't give you that? So you'd write down what you have here, and you're looking for D, right? And the way that I would do it, the way that I find it kind of makes sense to me is, A, we're not even looking for that one, right? We're not even, that's not even in like our question, and we don't even really care about it. So what I would do is if you go back to your formula sheet here, I'd look at these formulas. So you can see that one, that one, that one, and that one. And acceleration doesn't come up at all in this question, right? So what I do is I look at these formulas and say, okay, which of these formulas doesn't even have A in it? This one has A, that one has an A right there, that one has A. This formula doesn't even have A in it. That's the formula we want to use. I find that's kind of a quick little way of figuring out which one you want to use. Okay, so that's the one we use for that. And then just plug it in and you get 75 meters. And technically our answer is positive, but we don't really know what that means, right? The question doesn't tell us like, west or east or right or left or anything like that. So, okay, number 2, a car starting from rest accelerates. So rest is a big word there. I'd underline that as you're reading through it. Accelerates at 5 meters per second for an unknown time interval. If the car travels 250 meters in the acceleration period, what is the time interval? So we write down what we know. Rest meant 0 for V1. Acceleration's 5 meters per second. It's asking for the time interval, so we're looking for T. And our distance was 250. And maybe I should make one thing kind of clear too, that another little trick I guess here is that if you ever have 3 things like we have here, you can always find a fourth. That's kind of the rule with all of these formulas that we're going to be doing. Now, again, I'm going to use that same kind of method I did in the last one, where I'm going to say, okay, VF is something I don't even care about in this question, right? It doesn't come up in my data and I'm not looking for it. So VF I don't really care about. So if you go back to your formula sheet and look and say, okay, which of these formulas doesn't even have VF in it? Well, this top one does, right? VF is right there. This one has VF in it, and this one has VF in it. But this one over here doesn't even have VF in it, so that's the one we want to use. It has everything that we do want. So we look back here, and yeah, that was the one that I just pointed out on the formula sheet. So we're looking for the time interval. Now you might look at this and say, well, that's really confusing looking. Maybe I'll write this out again and kind of show you, not in typing, how that would look. So I wrote it out again without the like the change in and the arrows and stuff up top. Technically, that's not right, but just for the sake of simplicity, people do this, and I'm going to do it now. So I'm going to write it out like this, and we are solving for t. And I'm looking at this, I'm like, oh crap, there's two t's. There's like a t squared there and a t there. But another little trick, there's a bunch of little tricks here. Since this is from rest, what we can do is say, okay, v1 is equal to 0. So 0 times t, well, 0 times anything is just 0, right? So this entire term here just goes away. And what I'm now left with is d is equal to 1/2 at squared. Now we're getting a little bit easier, right? Now we need to rearrange for this thing. You can think about 1/2 times at squared. Well, that's really just the same thing as at squared over 2, right? That might be a little easier to rearrange. I find students have a bit better time with that. So I'm going to multiply both sides by 2. So I end up with 2 times d is equal to at squared. And then finally I've got 2 times d divided by a is equal to t squared. And then if I want t, I need to take the square root of both sides. So I've got the square root of 2d over a is equal to t. If you found that really difficult, make sure you practice it, because this is going to become a thing that we're doing all the time now. Yeah, so that's the rearranged formula, and then if you want to see the numbers put in, they're right there. So you can figure out that the answer is 10 seconds. Okay, but the big trick here, v1 is 0, crossing off that entire term, and then things get easier. Okay, number 3. An object accelerates from 5 meters per second to 100 meters per second. If the object traveled 250 meters during this time, what was the acceleration? So again, you'd write down what you know, v1, v2. Acceleration is what we're looking for, and it gives us distance. Now, the only thing that we don't even have in this question, and we don't even care about, is time, right? So I'd look back at my formula sheet and say, okay, which of these 4 that we're kind of focused on now don't even have time in it? Well, that one has time, that one has time, that one has time. This one, that's the only one that doesn't even have time in it. That's the one that we want to use. Okay, so that's the formula we got there. Now, rearranging for this, hopefully you can get to that point. Maybe I'll quickly go through it just as a review here. So we've got v2 squared is equal to v1 squared plus 2ad. Now I just subtracted v1 squared from both sides. Sorry about the small writing. So now I've got v2 squared minus v1 squared is equal to 2ad. And then all I did is I divided both sides by 2d. So divide by 2d, those cancel, and we got that divided by 2d, and that's how you get to there. Okay, hopefully that made sense. And then just plug it in your numbers, and you end up with positive 20 meters per second squared. All right. A ball rolls up an incline plane with an initial upward speed of 9 meters per second and stops rolling upward after 3 seconds. When it begins to roll back down the plane, what was the displacement after 3 seconds? So key bit of info here is it tells us initial velocity and that it stops rolling upward after 3 seconds. So that's VF is equal to 0 at that point where it stops. Okay, so we write down again what we know. In this question, acceleration doesn't even come up, and I'm not looking for it. So I'm going to use the formula that doesn't even have acceleration in it. Plug in your numbers. You get a positive number at the end, so it's going to be up the incline. Number 5, a car traveling east at 30 meters per second applies its brakes to generate an acceleration of 4 meters per second squared west. If the initial speed of the car was 5 meters per second east, how far did the car travel in the acceleration period? First off, I'm going to draw a little legend so we can make sure we got our east and west figured out properly. So that's east, that's west. So whenever the question says east, we're talking about a positive number. Whenever it says west, we're talking about a negative number. So V1 was 30 meters per second because it is going east, so it's positive, right? It applies the brakes to generate an acceleration of 4 meters per second squared west. So the fact that it's west is saying that it's negative. It's the other direction, so make sure you have a negative for your 4 meters per second. If the final speed of the car is 5 meters per second east, so it's still positive, how far did the car travel in the acceleration period? So again, time is the one of the 5 variables that doesn't even come up, and I'm not looking for it. So I'm going to use the formula that doesn't even have time in it. So now rearranging for D is going to be a really similar process to the way we solved for A up here. It's going to look really similar. You end up with this as your rearranged formula. Just plug in the numbers. Don't forget to square 5 and to square 30. And you end up with positive 109 meters. And we said that positive was east, right? It's east. Number 6, how fast will an object be traveling after falling for 7 seconds? So we know a few things here. We know we're assuming it starts from rest. We didn't throw it upward or downward. V2 is what we're looking for. It tells us in the question it's 7 seconds. And this is the one that is always the same if you're throwing it up in the air or down in the air. Negative 9.81. Rearrange just our formula that we were using in lesson number 7. Solve for V2 and you end up with negative 66.87, and it's going to be meters per second down. And technically, that shouldn't be with that many sig digs. This should be just 67 meters per second down. Sorry about that. Actually, for this page, don't look too closely at the sig digs because a few of them are actually wrong. You'll see that this one in the next question too, the sig digs are off a bit. So for this one, just maybe ignore the sig digs on this. So 7, a man standing on the roof of a building throws a stone upward 20 meters per second, and the stone hits the ground after 5 seconds. How tall is the building? Now this one I think kind of helps with a picture. So the person's on top of a building, they throw it up, and then it comes back down again. Now I just want to make sure that we kind of know what we're actually looking for when we say distance here, because people get this mixed up. Okay, so V1 is going to be the velocity right here, right? And that's going up. And that is negative 20 meters per second. Acceleration is always negative 9.81 meters per second squared if you're on Earth and you're throwing stuff up in the air. The time is 5 seconds. So that's the time it takes for this thing to go up and all the way back down to the bottom of the cliff there. And it's looking for the distance. So VF was the thing that never even came up in this question, and we're not looking for it, so I'm going to use the formula that doesn't even have VF in it. So I'm going to plug my numbers into this formula. Just nothing even needs to be rearranged here. Make sure you keep track of your negatives though. And if you do that, you end up with negative 222.6 meters. So just to be clear, this is a displacement, right? So this is actually the distance from here to here, and it's negative, so that means it's down. So you started here and it's down. It's not some people get confused on this and they think it's the all the way up and then all the way back down. That's what was 222.6 meters. But no, it's from where you started to the bottom. For example 8, I'm going to let you guys go through and look at this. It's all stuff that we've done, right? Yeah, so go through and I'll let you guys do this one on your own. All right, so that's it for this video. I'll go through the practice problems on the next video.